archive. So probably going to mute everyone's phone lines if we start to get some background noise. If your phone line is muted centrally here through my telephone, if you need to ask a question or talk, you're going to have to press #6 to unmute your line. We are going to have a question and answer session after the presentation. And if you take a look at the lower, I think it's the lower right-hand side on most of your computers, there's a little button that has a little hand in it. If you click on that button, you can go ahead and try it out now. That puts a little hand, it raises a hand. Carl Roberts, I see your hand is raised. Nick Kennick, it's working, and that can signal to me that you have a question, and then I'll call on people one after the other, because with this many people, we have to have some kind of way to orderly process questions in an orderly way. All feel free to use the chat function, which should also be in the lower right portion of your screen, to send me messages, and I'll then collect all of them, and we'll go through them also in the question and answer period. Okay. Before we begin, I want to make our standard disclaimer statement. EPA and Greenchill, we don't endorse products or companies, and I do want to make sure everybody understands that nothing in this webinar is meant to state or imply a product or company endorsement. So I'm going to hand over now to our two presenters, Harrison Horning from Hannaford Brothers, which is part of the Delays Group, Aaron Kausler, who works for Danfoss. And Harrison, I am going to give you control slides. So there you go.
Okay, Keely, can you hear me?
Mm-hmm. Yes, I can. Mm-hmm.
Okay. Well, welcome everybody. The purpose of the webinar today is really to share information and ideas in the spirit of the Greenchill Partnership. And this information that we're presenting is very new. Aaron and I have really been working on this only recently, and you're seeing it at the front end of the process here, and it's not yet perfected, but hopefully will give us ideas about leak detection, and in a way it gives some of the supermarket partners a way to make better use of limited resources, where you know a system by monitoring the receiver level, you know that this particular system is not leaking. Therefore, I don't need to send a guy there to leak check it today. And I might have a system where I know there's a leak, and I might be able to send a guy with maybe an expensive leak detector to that particular system and say, hey, know there's a leak, go find it, use this expensive instrument. So it's a tool that can help supermarket partners in a situation where we're all working with limited resources. And in the end, it gives people maybe a better understanding of refrigerant leaks. It's sort of a window into the inside of the system that is always difficult to see normally. I mean, refrigerants, flow around through refrigeration systems tend to be sort of mystical and happening, inside of the pipe. So here's a way to see maybe a different view of what's going on in there. As Keely mentioned a little bit about Greenchill, we report leaks annually and we set goals for leak reduction. Some partners use advanced systems, but we all really need to be looking at tools that we can use in existing stores. We all have, we might do a handful of new advanced systems on new stores, but the fact of the matter is there are literally thousands of supermarkets out there that are working today that have issues. So we're trying to address that as well. Keep in mind that the compliance rules still apply, that anything we talk about here today is over and above any compliance protocol or program that we need to have in place. It's possible that someday systems like the receiver level monitoring could be part of a compliance protocol. but that's something for future discussion. Let's be talking about the receiver. We're going to assume a conventional system with a flow-through receiver, not a surge type. And in this scenario, if you see a consistent drop in the level, it's going to generally indicate a leak. The receiver that we use at Hannaford are horizontal cylinders, usually, cylindrical tanks. Generally, can be either under, they can be either located with the compressors, or in some cases we put them up high. But it's something that's downstream of the condenser, and the level can be monitored. We can use various types of level sensors, and historically we've done that at the Hannaford chain, and people could either manually view some sort of a gauge or instrument, or there could be an automatic sort of a signal sent to a control system. And I found that in most cases there's some way to correlate the pounds of refrigerant in the receiver to the level, and it can vary depending on the type of receiver and the type of sensor. So let's talk level sensor. When we've got an automated system, we need something that puts out an electronic signal, and we look for an analog signal that's preferably proportional to the liquid level. We've used types over the years. Some that are sort of inserts from the top of the cylinder, and it's called a transducer, and it gives you a level reading just purely based on liquid level. The ones that we are using more recently, we prefer our float type, and we found a particular one that's linear through the circle of geometry, the float, and the way that it's oriented gives you a bit of a linear signal in spite of the tank geometry. So that's a nice thing to have. So in other words, if I'm looking at a receiver level and it says I'm at 20% on the sensor, then I can safely assume that I'm pretty close to 20% capacity in terms of pounds as well. Typically use 0 to 5 volt output. That's a pretty standard thing. And then that analog output from the sensor is an input to our control system. And at this point, speaking of control systems, I'm going to turn over to Erin, and she'll talk us through the controller and some of the other aspects of what happens in the control system.
Thanks, Ben. So for the control system, in talking with Harrison and some other people within Hannaford, it came up in conversation of, they have this liquid receiver level data, or interested in viewing it, but they weren't quite sure how to do that. There is a control system in each of their stores. At times there are more than one. Control system acts as the local brains for the store. They're multiple, doing multiple applications for refrigeration, HVAC, lighting. It doesn't matter if there's one or multiple. They're each performing the same function. System controller is used to receive, record, and store, whether it be refrigeration, HVAC, or lighting asset performance data, and can be related to energy, temperature, and operation. The system controller has the capability to, it is dependent upon the number of control points, the logging frequency of these points, and the system's ability to compress the samples taken. The system controllers also have the ability to communicate this collected data to other locations for further use and analysis. In the case of Hannaford, there's certain time periods that we are collecting and logging that data, and it was trying to find a way in which they can use it in a meaningful way. The controller has the ability to transmit this data. So in this case, we were looking at the liquid receiver level information, and what we were doing was taking this data and transmitting it via an Ethernet connection from the system controller into a remote data center where it can be accessed through a dashboard program. The ability to transmit this data can be done through modem or VPN. Hannaford's method, in the preferred method at this point, is a VPN access. VPN access is a much more secure and reliable connection, and it allows for a faster and larger bandwidth for more data points to be transmitted. The access allows the users on a much more increased ability for faster and in-depth analysis once that data is received. The information was collected into a central data center. We then populated the data into a dashboard. A dashboard is a KPI measurement tool that displays the operational data as usable information from either an enterprise, a division, or an individual store perspective. In the case of Hannaford, we are collecting data on multiple data intervals, whether it be 1 minute or 2 minutes or 10 minutes. In the case of liquid receiver levels, across their full enterprise of 180 stores, it's equated to more than 64,000 sensor data points per day that we were collecting. And the question was, how do we make this and present it in a meaningful way so that they can actually use it for diagnostic purposes? This view, the top slide is an overview of 3 racks in one store, setting a view of the rack performance. This is based on the raw data collected from the system controller. It gives you a larger time period, so you can actually see trends and identify, quickly if something doesn't seem right to you. You can also look down and specify to look at a specific rack, such as in the bottom example. If you do have a specific issue that you want to address, you can definitely hone in on that and spend more time focusing on maybe what is wrong versus, what's acting correctly. It can also be aggregated so that it's in a much more meaningful way and usable. In the top chart, we're looking at a 1-year time period of system data that's been collected on, I believe, 2-minute data intervals. This equates to more than 260,000 data points that we were populating. It does provide a trend, but at the same time, how to take that information, actually use it and apply context to it. In the screen, the ability for Hannaford through the dashboard to aggregate that data so that a single value or a much more manageable set of values to work with was done. Gave the ability to do, daily aggregations, weekly. In this case, we're displaying monthly aggregations, so you're getting one value per month. So we went from 260,000 data points down to 12, which is a much more manageable process. You do ability as the amount of data increases over time to do possibly quarterly and yearly comparisons on a store-by-store level, a rack-by-rack level, or even across the enterprise. The system itself, the dashboard, does display actual values as well. So looking at a specific time period, you can actually calculate based on actual data values and time periods, for specific purposes and specific analysis that you're performing. Like Harrison was saying, dependent upon the receiver tank level, the specific cost for refrigeration, actually calculating, what is the value of what was lost, or, apply a metric and a KPI baseline to say, this time last year we were at this point, here we are today, and actually apply either dollars or actual poundages to this is now doable for them. The data itself is also exportable into a spreadsheet format. You can take the raw data, in this case it's 1-minute data intervals, so you're pulling what was in the controller and now having it accept from your office, whether it's them or a contractor or a different division within Hannaford, to emulate and incorporate that data into an internal report, put it as external report purposes. You have the ability, based on how you aggregated that data, to export it as well. So you don't have to calculate, a monthly average or a yearly average. That's also exportable, which makes it easier and much more user-friendly for Hannaford. Considerations for the system controller include smart algorithms whether it's done in the controller or in this case in the dashboard, how can you proactively determine if you have an issue? Looking at an aggregated amount month over month and determine if, a specific deviation occurred, how do you alert someone to that? The current state we're in today is, just based on actual data values. If you program an alarm into your controller, say, it falls below 25%, I'm going to trigger an alarm in the controller. You have, specific actions on how to relate to that. But, if based on last month, if it's a 10% deviation, that may be important as well. And that's where Hannaford wants to go is, not looking at this on a daily basis, but, even if weekly they say, something changed by 10, 20% over last week, how can we address that and correct it in a much more timely fashion. Loading the refrigerant directly into the controller as well is an option. Number of color change, mid-size change, rely on contractors and logbooks that may reside in a compressor room or the back of a van to track, refrigerant was added on what date. By adding it and making it part of the control data in the system controller, we can now display that and overlay it with these graphical overviews of liquid receiver level sensor data, tying it back in to show when recharges occurred, based on user-defined logins, who was it, how much was it, what was the date, to provide some sort of validation and much more oversight into what's going on. Display it in the dashboard, using the control data to actually provide meaning and a bit further detail and analysis for someone sitting outside of that specific store, and provide much more of an enterprise overview where you can compare stores on, how much refrigerant was added and, during specific time periods. We're providing that kind of control and insight now for Hannaford based on the control data. So we'll hand it back over to Harrison.
Thank you, Erin. I'll touch again on some of the future directions when I get toward the end. Can you hear me?
Yes.
Okay, thanks. Re-emphasize. So the data is coming from sensor through the controller and then to the dashboard. And the dashboard is really a very powerful tool. You heard Erin mention, trying to use the tool to meet our needs, and it's great in terms of aggregating data, in terms of allowing us to manage it over. We don't want to manage some of this in real time, so we can look at it on a weekly basis if we prefer. And the most powerful thing of all is it makes it user friendly. I'm not the most technically savvy guy in terms of using technology. Now we have a tool that even I can use, and I know some of you on the call are way more capable than I am. So if I can, I'm sure you can. When we first started this, in fact, we didn't have the dashboard up and running. About a year or two ago, we were getting the data out of the controller and bringing it back and putting it into an Excel spreadsheet and graphing it there, and actually paying a consultant to do this for us and saying, wouldn't it be nice if there was a better way, and now we have it. So like I said, the dashboard has really taken us to the next level, and we're real excited where we can go from here. So to show you some of the data, you could, it's kind of case studies, if you will, but just more examples of what we can see with this. We really, like I say, this is all brand new, so I barely have time to analyze what we're looking at, but I want to share it with you anyway. And some of the things we came up with in terms of graphing, tips, if you will, is realizing that there can be a lot of volatility in the data, a variety of reasons. The best thing to do is take an average, and a daily average or maybe a weekly average if there's a lot of noise. It seems to work very well to capture those trends. And what I'm showing you here is a one-year period. The graph you'll see will be a one-year period, sort of a standard just for this presentation. It may be a good rule of thumb in general, but that's what I'm showing you. You could get that 6 months, 2 years, or whatever you wanted to do with this tool. Here's an example of a store with four racks or 4 systems, and I call no leaks. It's a fairly new store, and most of these lines are pretty darn flat. The one in every case, and I'll pull up a pointer here to show you, but this line is one that has a little bit of action to it. This might have been a 30-pound ad here, but overall things are pretty flat as you look at this one. So the point here is a lot of these systems aren't leaking. I'd rather have my guys focus somewhere else maybe. Or I call slow leak. This one has 3 systems. What I was going to do, the red is the low temp. In all of these graphs, the red is the low temp rack, and the other, the green, blue, and orange lines would be medium temp racks. Here we have what I call a slow leak. This trend we see here, and there was a little bit of an ad here. It's trending now, so that's one we want to focus on. And maybe the guy went in and added here, and then he did leak check and couldn't find anything. I mean, he probably found a leak and fixed it. Maybe it was a very small one, but the fact is I think there's still something going on there. So now we know this, and we say, hey, if you go back to that store, don't buy with the green system. The blue, by the way, that's probably got some heat reclaim going on. That's a very seasonal component to it, but when I see it's at the end of the year, it's just as high as it was at the beginning. I'm not worried about that one either. So a nice tool for knowing where we should be looking and where we maybe don't need to be looking right now. Here's an interesting one. I call this one recurring leaks. And here's a store, a fairly new store, probably only about 3 or 4 years old. And we have these recurring leak events on this green rack. And unfortunately, when you see this kind of a sudden drop, that can be a catastrophic situation. By the time you realize it, against this system, this is, we didn't have this in place back when this was going on. Without having a system like this, you can get these fairly rapid leaks. And the time you respond, you've lost a lot of your charge, or maybe even in some cases the full charge. These have a story, and this is the story is that we have component failures in the cases. Would be a fluid line filter dryer, a suction stop. Maybe we have pipe chafing. Maybe it's a liquid suction heat exchanger. Too many component failures. Maybe bad batch, whatever. But we really, this is an example of we need to be working with the suppliers and them working with their component manufacturers to do whatever is practical to furnish tight, leak-free equipment to the supermarkets. These, unfortunately, they just seem to keep happening. Medium leaks. These are my own terminology here, but you can see now some of these. And oh, by the way, I'm not as savvy as Aaron in terms of. I didn't take out. I could. Use just one system. I could isolate a system, but what I do is all the racks in the store or all the systems in the store. Again, here the blue one is fine. Just kind of ignore this. I think one of our technicians went rogue when he heard I was doing a webinar. He said, "Oh, I'll fix them. I'll move refrigerant back and forth or something." But forget this piece for now. What we're looking at is this leak here. A fairly good rate was found. Recharged and fixed. I'm happy with that until this, of course. One was thought it fixed, but guess what? I don't think it is. So I think now we want to go back and revisit that. So another example of what you might see. There's another one, medium leak. This is a little bit steeper slope, maybe. This is an older store, so some of the older level technology, and it's a little less stable and maybe more heat reclaim going on where the systems jump a little bit more, but we were able still to see this green system definitely a leak here. addressed, recharged, and seems to maybe be okay. We'll keep an eye on that one. The other ones look pretty good. This one might have a slow leak, so we can maybe do some work on that one. Here's one called fast leak. Pretty steep drop. So if this is 70% and this is 25, that's dropping about 5%. And we figure we tend to go 3 to 5 pounds per percent. So it could be 150, 200 pounds. Pretty hefty number. Something we want to be aware of. And was addressed. It was obviously here. Maybe it looked fixed, but wasn't. Here, much better. So keep an eye on that one. So you have some examples. I think it's kind of an interesting view into what's going on inside of some of these systems. And so when I think about what we want to do next at Hannaford with this is keep working with the tool, and we're going to be expanding it to use it on more stores, working with Anfos on that. Try better handheld leak detectors. Like I said, if I know if I know a system where there's a leak and I can see it, and many of us have technicians out there looking for them. Sometimes it takes a long time to find them. If we had better leak detectors in the field, maybe we could do it more efficiently. And if we had, even if they were more expensive, if we were to target them, in other words, I don't necessarily need to buy one for every technician, but maybe if I have one per region, we can shed and say, hey, what are the ones we think are leaking? Where we want to send the leak detector this week or something. So I think that's an opportunity there, and maybe the subject for another webinar on handheld leak detectors. We want to get suppliers to furnish tighter equipment. As I mentioned earlier, I just think this is an important area, and it's an ongoing thing, and I know the suppliers, most of them are aware of it and want to work with us on that. We can, we just need to keep working on it. And building algorithms for automatic notification. Aaron touched on this. Call it an alarm or a sort of soft alarm. You can if you're getting a reasonable signal into your controller, you always have the ability to use it to set up as an alarm, if you will. In other words, when the receiver level gets below some percent, create an alarm. Sometimes, I guess, in my opinion, you might not want that because of the volatility. You don't want spurious alarms. So for a soft alarm generated from the dashboard, meaning the dashboard is pulling data from the controller and it's processing it maybe on a daily or weekly basis and saying, hey, you want an automated computer algorithm to say, hey, we've been looking at this for a while. We detect a continually decreasing level, therefore, and it's gotten to a certain threshold, therefore we think it wants an automatic email to somebody to let them know this is go look at this system, and then somebody can pull it up on the screen and analyze it with the graphs like I just showed you, and then go from there in terms of dispatching a technician and a leak checker and so on. And of alarming that is done can be sort of coordinated, so that it becomes a part of the program, if you will. One of the areas we want to look at into the future. So, conclusion, we've shown that the data from supermarket control systems can be useful in this grade to reduce emissions. And in particular, the automatic receiver level monitoring helps us in many ways, and ultimately helps leaks, which is the main goal. At this point, I think we can open it up to questions.
Okay, Harrison. That's really interesting, and we have. I've been accumulating a whole bunch of questions here on chat line, And for everybody here on the line too, don't forget, if you have a question, go ahead and click on that hand that's on the lower right-hand corner of your screen, and I'll kind of keep an eye out for hands. But until I see any, I'm going to go ahead and get started on some of the questions that people have been sending me here. First one is, how often does the liquid level device require recalibration to ensure accurate data is being logged?
I'll take that one. I don't know the answer to that. We don't worry a lot about calibration. There is somewhat of a truth theorem in terms of technician. If the receiver level is indicating very low level, technicians have other ways of verifying that in fact the system is at a low level, and the same thing at a very high level. So I think we get a pretty good indication of very high and very low. I've never really thought about calibrating them, and I should mention that the sensors that we use, I believe, and I don't have the data right in front of me, but I believe they're rated to be fairly accurate in a certain range, like maybe 20% to 90 or 100. But I think when they get below a certain range, or maybe even above a certain range, they're less accurate, and they tell you that right up front. So we are aware of that. So that is an issue in terms of how accurate the data is. But calibration is a good question, and one that I really have never thought about.
Okay. How is the ambient temperature used to base what may be happening to a liquid level? Is it considered?
A good question too. And one of the reasons we got into this was when we started using systems that were largely unaffected by ambient temperature, because the fact is that depending on how you do heat reclaim, the temperature can have a significant impact, and that we saw two of those traces where you saw a big seasonality. When you have that situation, it's what I was doing for brute force here in the first cut is look at a year ago, what was it 12 months ago, and what is it today, and are they close to the same? And at the same time of year, are we in the same ballpark? And that's a gross check. But I think the person asking that question brings up a good point. When you have systems where the receiver level is clearly affected by ambient temperature, you need to take that into consideration.
Right. And as Harrison and I go forward, there's that to allay the ambient temperature, because it is a controlled data point within those graphs, is something we could work on going forward if that's how he wants to see a correlation.
Mm-hmm.
Okay. I'm looking here. I don't see anyone who has raised a hand. Just stick here to the questions I have by chat. Did Hannaford already have the correct sensors in the receivers, or were they installed as a program? If the latter, what was the estimated cost of the rollout? Harrison, I know that cost data is often a sensitive information, so leave it up to you how specific you want to get there.
We kind of got lucky, and the sensors that we like, if you will, started going in about 3 years ago, and as it turned out, they were very compatible with this program. And so the fact is we had the sensors already in place. About 25% of the Hannaford stores have the float type, and that's very well. The other kind work too, but the fact is not had to roll out a program to install these sensors. They were already in place, and I actually don't really know a good number to give you on the cost. So I just don't know a good number to give on that.
Okay. Here I have a hand. Greenchill partner Stephen Mitchell. Go ahead.
I was experiencing the same problem with the leak detector. I'm trying to find a good leak detector for my guys, and one took a different path. I tried this fluorescent. It's that, I guess it was that fluorescent dye we put into the systems. Are you familiar with that?
About it.
Yeah, I tell you, we went on an ECM motor program where we emptied all the cases, and what I did was about a month prior, I loaded the system with the dye, where you need a special flashlight for, and I've experienced huge success. Because the cases were empty. When we did the motors, I sent in one of my refrigeration techs the flashlight. They did the when they all open, we found little shredders, we found we checked expansion valves, transducers that might have been, and things that the electronics didn't pick up. They had that opportunity, but we found that we found indicators where leaks were. And it's a standard practice when a guy works in a case, he pulls out his flashlight and he checks and leak checks, whether it was a tight system or not. But we're just using that. So I don't know if that is a help, but we've been wrestling with different means of leak detection as well. And I just wanted to share with all the partners that that dye has been huge success.
That sounds like a great topic for one of our next webinars.
It's quite involved. It's not as easy as just putting dye in, and I know there's a lot of cheaper dyes, and this is a quality dye and a quality system. It required some training. What I did is I had the guys, everybody had to get some certain amount of training, but it's and really nice about it is you could easily find leaks out on the condenser piping and in the fins and condensers. So that's what you can't do with electronic. I think it's impossible unless you tend to.
Okay. Oh, I'm gonna. You can be sure I'm gonna give you a call.
Okay. Looking forward.
Consider yourself warned. Okay. I'm gonna move on here. So please explain what the algorithm uses for inputs and outputs. Details, ambient temp input, liquid level input, alarm outputs, etc.
There are no algorithms. It's true controlled data input. So it's a temp sensor, and it's recording a temp value. That's what's populated into the dashboard. A future state that we're working towards to develop those algorithms that takes the raw data, the actual control data, and puts a little bit of thought and calculation into it.
Do you have any indication, Aaron, in working on developing algorithms, you have any indication of where the best place is in terms of inputs that you'd want to start with?
You mean inputs to use?
Yeah.
That's not. I mean, that's an R&D kind of conversation, but if there's something specific in mind, or it's definitely up for discussion.
Okay.
I think the way I see it is what would help Aaron the most would be to sort of understand the thought process of some of the supermarket partners. When if they were looking at this data, what would they think? In other words, where would they want to focus? And if you can sort of capture that thinking into a computer algorithm, it's almost an artificial intelligence thing. And I know because this isn't out yet, and it's been hard for Aaron because I keep saying I think maybe we should look at this as an indicator, and then I change my mind the next day when I look at another graph. And so it's just trying to capture in an algorithm, what is a graph that says hey, this one should get some attention. And there's another side to it that says that may look at the other way and say, nope, this system, this one alone for now. Go look at another one or something. Right. So you're looking at which ones need attention and which ones don't need attention.
Yeah. And R&D is currently working on a COP calculation based on industry standards, and granted a lot of it's based on European regulations and how can you predict and really attribute some significance toward refrigeration and adding refrigerants and inputs along that line. So I know that there is current work going on regarding a COP tool, and that will come out in the next couple months if that's what you're looking for.
Erin, what is a COP? Correlation of performance. Okay.
Coefficient of performance.
Okay. Right. What does the application in the controller record? Does it record initial charge and estimate the leak rate? EPA approved for leak rates. Okay. The EPA doesn't approve equipment or leak detection equipment or anything like that. But I think the gist of the question is, are you able to use the information you get somehow? How do you deal with the information you're getting and what you're required to record by EPA? Does it have anything to do with each other?
I think the basic answer is no. The controller is only really getting the level signal at this point. Now, I mentioned future state could include other data. Be able to think about use controller for more things than what we're doing right now. But at the present time, it's only getting the level signal. I think that answer the question.
I think so. If not, certainly, if anybody needs more clarification, or if I maybe didn't phrase the question correctly, feel free to raise a hand. Greenville partner Frank Davis, go ahead. I think that you probably have to hit #6 so that we can hear you.
Can you hear me?
Oh, yeah, good. Go ask your question. I think we lost you again. I'm gonna move on here and ask the next question, and in the meantime, we'll try to get your unmuting and muting straightened out. How many pounds lost per % drop in receiver level is the next question.
For the that I showed, it's between 3 to 5 pounds per %.
Okay.
Our newer systems are lower charge, so the receiver is probably closer to 300-pound capacity, and some of the older ones are closer to 500. So 3 to 5 pounds per %.
Okay. Well, that actually probably answers. I just want to go to this one slide here that showed. Oh, somehow I can't. Of course I can't find it right now. But okay, this one. So for instance, what I also was curious about, if you look at the green line here, so you see. So in October, you realize that you have a downward trend that started, looks like in about June. So, how do you know, or at what point, you really do have a leak and it's not just a fluctuation up and down. So for instance, in this case, so how comes you didn't go in July or in August?
Oh, we turned the system on in October. When you see that big green ad there, that's pretty much the first time we ever looked at this one.
Oh.
The question is, if we were to go back and say, if we had looked at it in July, would we have known that's a leak and not a seasonal thing? And maybe yes, maybe no. But by August, we would have known.
Okay.
And,
so if I look here,
Go ahead.
From June to July, it looked like it went from, about 36 down to like about 33. And you're saying, though, that probably represents about 10 pounds of refrigerant.
In this case, probably more like 15, yeah.
Okay. So that puts it into context a little bit. I guess when you look at the picture and you see a really steep slope like that, for some reason it makes me think hundreds and hundreds of pounds of refrigerant. So
I'm guessing those ads, they may have been 100-pound ads nominally. No,
okay.
There's 2 green ones and a red one, and the things we're all trying to avoid. That's money and it's emissions, and I start with money because that's sort of what is most important to most of the supermarket partners. But that's we're trying to avoid, and so we either reduce the number of those ads or the volume of the ads or both. That we're going to come out ahead.
Right. Jeff Bowery, do you have a question? You have to hit #6 so that we can hear you.
Yeah.
There we go. Ahead.
Notice on the graphs, the receiver levels are in the 20-30% range as a norm. Just curious from some of the other partners, what type of what levels of refrigerant are they attempting to maintain? We've noticed that it's extremely site specific and have had real good luck reducing the on-site holdings of particular receivers with some cooperation with a technician on-site to identify that the liter stays flooded at a given receiver gauge reading, generally much less required than we've been taught for many years.
Yeah, I actually I can comment on that. That's one of the big changes in attitude out there that we have been noticing in conjunction with Green Chill's store certification program. So one of the standards that you have to meet is, in order to achieve silver level certification, that represents approximately a 50% reduction in the refrigerant charge of your system. And that made an awful lot of people start thinking about whether they really need all of that refrigerant in their receivers. So I've had a lot of partners that have told me, instead of this, these incredibly high percentages in receiver levels, they are actually finding that 30% or say 40%. It ranges across the board, but a lot of people that are achieving Green Chill store certification regularly, I believe a lot of them are probably at around 30%. I'm sure if anybody's lower than that. And in terms of EPA and in terms of Green Chill, what that basically means is if you do have a catastrophic leak, you certainly want to be leaking as little refrigerant as you possibly can. And if there's no reason to have the receiver just holding all kinds of extra refrigerant, it can also save you an awful lot of money in your initial refrigerant charge, to reduce that level. So I don't know, Harrison, anything else to add to that?
I agree with what you're saying, and the only caveat is that, as I mentioned before, that some of these level sensors are rated down to maybe 20%. So if you were to specifically see your level below that, you'd just want to make sure that you were still getting a decent signal. I mean, they won't work. It just means they're not rated as accurate. So that's the only caveat there. But certainly, most of the graphs I showed were probably in the 20 to 30% range. I think that's kind of what we shoot for.
Okay. Do the stores also have stationary leak monitors?
No.
Okay. How long did you monitor before you had useful data without a lot of false alarms?
That's a good question. Yeah, we don't like false alarms, and that's why we're still working on the alarming feature, is to get something that's providing, generally providing useful information, and generally not providing spurious alarms, false alarms.
Right.
So we're working on it to answer the question.
And what Harrison was saying, we really, started putting on this just recently. If controller has data logging in the controller itself, and go and you start populating a dashboard today, you'll get the history what is in the controller. So even if you start today, as long as the controller is holding data, it'll populate where you might years worth of data starting today. It's not like it would just turn on today and that's where you start from.
That's interesting. Okay. So Harrison, that's what you meant when said about on slide 23, when you said about that kind of just turned on the system. So you turn on the system.
We weren't even able to see this graph until recently.
But the data was in the controller, and the fact that I went in and pulled it, that we got over a year's worth of data, but it's just because we started looking at it and populating it recently.
Okay. All right. Okay. Have you seen instances where floating head pressure or a winter valve caused possible false losses or gains of refrigerant? What is the common liquid level percent expected, or is there one?
The liquid level expected will vary depending on the system, and but the answer is we see that, and if you look at it in real time, it can be a big jump up down depending on the season. If you look at over a year, like the graph showed, you should see the complete season cycle. So you get for level. A gross cut look at the beginning of the year, the beginning of the graph and the end of the graph, and are they in the ballpark? And doing that every week, for example, you're always kind of always on top of it. So let that seasonal cycle, look at it on an annual basis, if you will. Look at it as an annual graph, and there is one way to sort of ask that seasonality, if you will. But in time, it certainly can be a big variable.
So Harrison, on the slide that we're looking at, so if you look at the orange line, so you see there at October 2010, or let's say November 2010, you're up at about 33, 34%.
Mm-hmm.
The same time this year, it looks like it's down at about 15.
Yep,
so would be a long, slow leak. Okay.
Yes. Yes, okay. I don't. There were one or two that I show where you had a seasonal cycle. I don't think showed one that had that step change with the winter valve and that sort of thing. But you can see that, and some of them we see that where there's a thing that clearly you go into a winter condition, you might 4 months or so where you're at a different level by 20, 30, 40%, can be very significant. Okay. And it can even involve an add or a roll of refrigerant. You can change it. You can actually have to add or remove refrigerant to support those seasonal cycles. So in addition to the receiver level changing, you might actually be changing your, putting refrigerant in or taking it out, depending on the system. Hanford, we don't see that as much on the newer systems. We've kind of been moving in a different direction, but there are a lot of old legacy systems out there that still operate that way, I think, in parts of the country.
Okay, interesting. Well, I see, I actually realized I wasn't even watching the clock. I see that we're at 3 o'clock. Obviously, anybody who would like to have more information, especially about how they can start looking at this type of thing for themselves, I'm sure that if you contact Erin I'm sure she'd be very happy to give you as much information as you'd like. And I know Harrison is always very, very willing to information related to anything that has to do with leak tightness. And he is a fantastic resource also. So I want to thank both Aaron and Harrison for a great webinar. I learned a tremendous amount, and I'm actually hoping that this is just one in a whole series that we can do about using different types of automatic control data to try to do a better job detecting leaks earlier, or eventually we might even get to the point where we can start preventing leaks using some data. So thanks again to our presenters, and thank you everybody for attending, and have a good rest of the day. Bye.
Though disconnected, the conference we terminated